So you've built a statistical model, you've put in the work, but how do you actually know if it's any good? Today, we are going to break down exactly how you can measure your model's performance in a really clear step-by-step way. Let's dive in.
This is the big question, right? If your fancy, complicated model isn't doing a whole lot better than a simple, dumb guess, then what's the point? This is the problem we're going to solve today, and trust me, it's way more straightforward than you think.
Okay, so step one, we need a baseline. Before we can say our model is great, we have to know what we're up against. We need to understand the full size of the problem we're trying to solve. And we're going to do that by starting with the simplest guess possible, just the average.
Take a look at this first line for total variation, or as we call it, SST. Just picture a bunch of data points scattered on a chart. If you had no model, what's your best guess for any point? Well, it's just the average of all the points. SST is what measures the total error of that simple guess. It's how far off every single data point is from that basic average line.
And that's the key thing to remember about SST. It is the problem. It represents the entire amount of variation, the total uncertainty in our data that we are hoping our new, smarter model can explain. You can think of it as the score to beat.
So yeah, to boil it down, SST is just the total gap between what's really happening, the dots, and that super basic guess, the average line. All of that messiness is our starting point.
All right, so we've got our baseline, our total problem. Now let's bring in the hero of our story, our new model. This is a regression line that's actually trying to fit the data intelligently. But, no model is perfect, and we need a way to measure just how imperfect it is. Now, look at that second row. This is the unexplained variation, or SSE. This is super important. After we draw our new, smarter regression line, SSE measures the error that's left over. It's the distance from each data point to that new line.
Think of it this way. SSE is everything our model missed. It's the randomness, the noise, all the stuff that our model just couldn't quite figure out. It's the unexplained piece of the puzzle. So you see the difference? SST was the error from just guessing the average. SSE is the error that's left over, even after we use our smart model. And of course, the smaller the SSE, the better our model is doing. Okay, so we've got the total problem we started with, and we know how much error our model still has. But what about the good news? It's time to measure how much our model actually helped. This is where we get to see its real power. And that, my friends, brings us to the third row. This is the payoff. This is the explained variation, or SSR. This part isn't about error at all. It's all about the improvement, the success of our model. Yup, SSR is literally the success story of your model. It's the number that tells you how much of that original mess you were actually able to clean up, to explain, thanks to your model's predictions. This is the big showdown, right? SSR measures the difference between our smart regression line and that dumb average line. It is the proof that our model is actually doing its job and capturing something real in the data. Now, I know it seems like we're juggling three different things here: SST, SSE, SSR. But the amazing thing is how they all click together perfectly into one simple, beautiful idea. When you think about it, it's just common sense, right? The total problem you started with has to be made up of two parts: the part your model solved and the part it didn't. That's it. And that simple idea gives us one of the most elegant equations in statistics. SST equals SSR plus SSE. Total variation equals explained variation plus unexplained variation. The whole is just the sum of its parts. It's that clean. So let's just walk through that logic one more time. 1, you start with a total problem, SST. 2, you see how much error is left over after your model does its thing, that's SSE. And 3, the difference between them, well, that has to be the power of your model, SSR. Okay, you've made it through the core concepts. You ready for a quick pop quiz to see if it all sunk in? Let's do it. All right, question number 1. Which term represents that big total amount of uncertainty we started with? Our baseline score to beat. What was that called? You got it. It's the total variation, SST. That's our baseline, the whole problem in a nutshell, when our only guess is just the simple average. Okay, next one. A little bit of math, but it's easy, I promise. If your total variation, your SST, is 100, and the error your model missed, SSE, is 30, what does that make the explained variation, SSR? It's gotta be 70, right? Because if the total problem is 100,
and 30 is the part you missed, then 70 has to be the part you explained. SST equals SSR plus SSE. Simple as that.
And really, that's it. You now have the fundamental framework for judging pretty much any regression model you come across. So the only question left is, with this new power to measure and understand, what patterns in the world are you going to go out and explain?